astrophotography. But I don't know of anybody more qualified to talk to us about the science behind the search for extraterrestrial intelligence than Scott. So Scott Kindt, thanks for coming tonight.
Thank you, Joe. Well, thank you all for coming out tonight. Speaking about astrophotography, so as Mr. Wilson was saying, I give presentations all over the place, dozens and dozens of them on astrophotography, and I'll give a 45-minute talk on how you take astrophotos. And when I'm done with the talk, guess what the most common question is I get every time? Mr. Kindt, have you ever seen a UFO? And go figure, every time. It's like, what did that have to do with astrophotography? So here I am. So it's something I'm passionate about, and that's why I'm here before you to talk about ufology and SETI and what it's all about and the science behind it. I'm not sure if there's one person that's a specialist in it. I think everybody knows a little bit about it, and I'm going to try to come up from a very neutral, biased point of view. Most of the presentation will focus on what SETI is, and then I will touch on ufology, which is the study of UFOs, unidentified flying objects, and is it science or is it not science? And is there a connection where maybe the two overlap, or are they on opposite ends of the camp there? So that's what our presentation's about tonight. Just a little bit about myself. Mr. Wilson had mentioned about astrophotography. So I was born in '66, so if anybody is close to my age, you grew up with the Apollo missions. And I have incredible memories of, I don't mean this in a bad way, my shows being interrupted because of the Apollo moon landings, Apollo 11, and just, I would go to the library and I would just get stacks of books on the Apollo missions, the Geminis, astronauts, and those are my heroes at the time. That's who I worship, that's who I idolized, was, you know, those astronauts at the time. And I don't think this made it into any of the science books, but in 1973, Scott Kindt, using a little 60mm Tasco refractor, discovered that the moon was round. And I can remember it like it was yesterday. I went running into the house, Mom, the moon is round. And of course, you know what any mom's going to do. She's going to be like, really? That's great, you know? And that was my first experience of an astronomical discovery at the time. And I call it a gateway drug. Astronomy is like a gateway drug for me that led me into the sciences. And I try to do the same thing to inspire my students. That's why we have this observatory here. People realize how wonderful astronomy is and how it leads to careers in science and engineering. And that's kind of how I got started. So growing up with astronomy, looking at the moon, it was a crescent moon like tonight where you could see the curvature and the craters, and I'll never forget that. But seriously, getting into the topic here, SETI, you might have heard of the name before. It's an acronym for Search for Extraterrestrial Intelligence. A little bit different than just searching for life. It's actually searching for intelligent life. So anything that fits under that umbrella of looking for life would be under the umbrella of SETI. And if you read the mantra of SETI, it reads kind of like a Star Trek beginning where boldly go where no one has gone before. Kind of the SETI is to explore and understand and explain the origins and prevalence of life in the universe. That's what they're about. There's the SETI Institute, that's what most people think of, but there's many offshoots of SETI looking for extraterrestrial intelligence and what that's all about. Many people first heard of SETI with that famous movie in 1997. I've seen that movie over 50 times. I show it every night in night astronomy class. Never get tired of it, okay? So Jodie Foster, 1997 Contact movie, was based on the real deal, which is Jill Tarter, which is what the book is about back there that we're selling. So by all means, pick up a copy of that book. But great movie. Can't see it enough times. Every time I watch it, I find out something new. It was written by Carl Sagan. It's, to me, one of the few science fiction movies that's got a lot of good science in it and some science fiction, and the book is also good too. So that's what kind of made SETI, you know, got it on the map, got it on the radar, got people noticing it. But if you're going to look for intelligent life, where do you begin? How do you start? What's the best method to look for intelligent life? It's really not into the deck of cards to travel there. I know Virgin Galactic just reached the edge of space, but you know, they're not going to be heading to stars anytime soon. So how do you find out if there's intelligent life out there? Most scientists and astronomers would agree radio astronomy is probably your best bet. All right. There's still some controversy about that, and they don't put all their eggs in one basket and look in just radio astronomy. But then when we think of radio, I'm a ham radio operator, and I've learned a lot about radio over the years, but most people just turn on a radio and they turn the dial and they get a station. What they don't realize is there's all these other frequencies where there's nothing but static. And what do you pick? What do you listen to? So you have a giant radio dish. What frequency do you tune it into if you're looking for extraterrestrial life? Well, as it turns out, there's something called the water hole. Not to get too technical there, but it's basically between hydrogen and the hydroxyl radical. There's a frequency on the dial that's relatively quiet. There's not as much static in there. And most scientists agree that if someone were to send an extraterrestrial signal, it would probably be in that band between 1.4 and 1.6 gigahertz. Where that is on the band is your cell phone, which is about, make sure I have mine. Okay, your cell phone's about 0.8 gigahertz. So it's in the microwave region. So even though they call it radio astronomy, you're actually kind of in the microwave region. And that's the frequency that most astronomers agree on would be the best frequency to look for intelligent life. You're also limited by what can come through the atmosphere. You can't just pick any frequency you want. If you were doing ultraviolet, well, you're going to have to build an observatory to get high above the atmosphere to get certain ultraviolet frequencies. And there's other frequencies in the infrared that are blocked by water vapor. So you're kind of limited to what actually comes down to the Earth. Well, as it turns out, the frequency in the water hole is at 21 centimeters, so it's right over here. So we're kind of in this range where the cell phones operate. Some of your wireless communications. That's the main frequency that much of the SETI work is done. Not all of it, but a good bulk of it is done in that water hole region. Because if they're an intelligent civilization and they were going to beam a signal to us, that would make sense of where they would look. Then the next question comes, do you look close to home for very weak signals, or do you look at galaxies? So what do I mean by weak signals? For the past 100 years, ever since we've developed radio and TV communications, we have been sending out signals to space unintentionally that seep through our ionosphere, travel at the speed of light. So within that 100 years that we've been seeping out radio waves, there's about 15,000 stars now that have now been bathed in our radio signals. And if they had a dish aimed at us, that was a big enough dish, they would be picking up our TV transmissions. I can just imagine something was 40 light years away and it's reality TV at its best, and everybody's waiting to find out what happens to Richard Nixon, you know? They get this information and they're just waiting for the next day because they can't get the news any faster than the speed of light coming to them. So it would make great reality TV. So we kind of do the reverse. Well, if somebody else has radio and TV communications, let's aim a dish at them and wait for the signals to come to us. That's the most logical thing. So most of the SETI work is done, if this is the Milky Way and we're a little bit more than halfway out from the center, it's done in a small region relatively close to where the Earth and the solar system is. There are some projects that have looked at actual galaxies, but if you were getting a radio signal from a galaxy, boy, that would be so powerful. I mean, those are millions of light years away. So to send a radio signal from a distant galaxy that would be one advanced civilization to do something like that. So most SETI work focused on things close to home. The first SETI project, which I'll show you, was just, within 15 light years from Earth, which is relatively close in terms of stars, because if you look at our Milky Way, from edge to edge, it's 100,000 light years across. So that's what makes sense from a scientific point of view. Just like if you're a new kid on the block, you make friends with people in your neighborhood. That's who you look for. You don't look for somebody in Serbia to make friends with. So the same with SETI. You look for close to home and work your way out from there. You might have heard of the Kepler mission. It just wrapped up, in fact, on my son's birthday on October 30th. They just ended their mission. It was about 9 years. And the job of the Kepler satellite was to look for planets outside of our solar system. Now, when I started teaching, the words in the textbook were probably like, we think most suns have planets, but they didn't know. There wasn't verifiable proof. Now we assume that, we don't assume, we know that it seems like most stars have planets, and many of them have Earth-like planets, and I'll give you some of the numbers here. If there's 400 billion stars in our Milky Way galaxy, and just say 10% of those are in what's called the habitable zone. The habitable zone is also called the Goldilocks zone, where you can have liquid water. And if just one of those, or 1% of those, has liquid oceans, the numbers come out to be about 400 million planets in our Milky Way would have liquid oceans. Now think about that number for a minute. 400 planets in our Milky Way with liquid oceans just like Earth. Put that in perspective of the US population. And you know what that means? There's a planet for every one of us out there. Talk about a real estate investment, huh? So, and that's being on the conservative side. Some people have estimated it's a bit more. So it's mind-boggling to think how many planets are out there. So here's a list of some of the nearby stars. The first SETI project, looked at this star, Epsilon Eridani and Tau Ceti, two red dwarfs. This one, the Tau Ceti, actually has an Earth-like planet that was relatively close by. And they kind of work their way out. They study the close ones first. Alpha Centauri is our closest star. That's about 4.5 light years away. So if you were to send a radio signal to Alpha Centauri, you'd have to wait 4.5 years for it to get there, and then 4.5 years to get back, a 9-year communication lag. So the distances are mind-boggling. When you think of our solar system, everything is relatively close. But when you start looking for life outside of the solar system, you take a quantum leap in distances. Okay, a little bit of history, and this could be an entire presentation just on the history of SETI, so I'm just going to touch on it. Nikola Tesla, very famous name, you know, the Tesla car, brilliant man. He came up with the idea of once radio had been invented, what a great way to listen for extraterrestrial life. He actually thought he heard signals from Mars. When they looked at the data, it appeared to be some type of geomagnetic interference of the Earth. If you have a ham radio operator, you hear all kinds of weird signals on the band as you tune in. But he thought he was listening to signals from Mars. And 1924 was the National Radio Silence Day. 5 minutes on the hour, every hour for a couple of days. All radio broadcasts were to cease, shut off, because Mars was in opposition. It was in a very good location. And they lifted a receiver 2 miles above the ground to listen for signals from Mars. It was legitimate science. They wanted to hear if anything was coming from Mars. They didn't hear anything, but you know, it's the start of it. It got the ball rolling, got them thinking, you know, radio, what a great way to see if there's life out there. Karl Jansky is kind of the father of radio astronomy. And these next ones I'll show you individual pictures of. This gets into radio astronomy itself, but he was engineer at Bell Labs, built this merry-go-round antenna that he could rotate, and it was looking at different frequencies. I think it was at 20 megahertz, and he got a signal, and it was the old chart recorder. If you've ever seen the pen and the paper and it kind of goes up and down, it was the old chart recorder, and it repeated every 23 hours and 56 minutes. Now, if you're an astronomer, that means something. That's sidereal time. That tells you it's coming from outside of the Earth, because if you were to look at a star, it'd repeat back every time at that time interval. And it was strongest when they aimed it at Sagittarius. So he put 2 and 2 together, and he realized he was picking up the center of the Milky Way galaxy. It was the first time a radio telescope picked up something outside of our system. That was the birth of radio astronomy. He wasn't a radio astronomer, he was an engineer. But very often that's how many discoveries are made, like the cosmic microwave background radiation was made by engineers in the same way. Today, look, and what he would have had was just a chart recorder. It wouldn't have been anything beautiful. Look at what we have today. This is with the Australian Desert Telescope. It's a radio telescope, so they have to color code it. Where the intensity is greatest, it would be kind of a reddish white color, and where it's coolest, it would be a black color. And this antenna array, look at that beautiful map it made of our Milky Way galaxy and the Large Magellanic Cloud and some of the nebulas off to the side. So compared to where we were in 1932, with just a static pen recorder, to what radio telescopes can pick up today is just day and night difference. So it's still a relatively young field, but they are making strides of progress. Here's the father of what I would call SETI. His name is Frank Drake. You might have heard of the Drake equation, 1960s. He really got the ball rolling. There's the famous Drake equation. He used the 26-meter radio telescope at Green Bank, West Virginia, which is a radio quiet zone where you don't have radio interference there. They don't allow cars with spark plugs. Everything's diesel to cut down on all that interference. And him and his team looked at those 2 stars that were within 15 light years of the Earth. And if you read about the time period, they were all excited. They're like, we got this dish and we're going to aim at these stars. And oh, they were so excited, like they were going to make contact or hear a signal or something, you know. And that got the whole idea of SETI started. So they scanned for 4 months, 150 hours on a chart recorder. Nothing came up. But their enthusiasm continued. It got the whole idea going. We can use radio telescopes to aim at distant planets to try to pick up signals. The famous Drake equation, I remember studying this in college. This is my kind of equation, because you could put any number in between 1 and 36,000 and you're right. Okay, you can't go wrong with that. It's a great equation, but it's not really an equation like we think of it as an equation. Frank Drake actually came up with this equation as talking points for the first SETI conference. Carl Sagan was coming, famous scientists were coming. What are we going to talk about? So he said, well, one of the things we need to find out is how often do stars form? How many stars would have water? How many stars might have life? How often does life form? So he came up with this equation where n is the thing we're looking for. How many intelligent civilizations are in our galaxy? Now, when I first started learning this equation, there were more variables. Now, these numbers, which are in white here, have been pretty well nailed down. The rate of star formation, and these are all very conservative for our Milky Way, about 7 stars per year, 7 to 10, but we're being conservative here. The number of stars with planets in our Milky Way, once again, that's a conservative number, about 75% of them. It's probably more like 90, but we're being conservative. The number of planets in the habitable zone that can support life, they say a little over half of them, but we'll go with 0.4. Those are realistic numbers that these guys, we didn't know about when I was learning this stuff in college. As time marches on, all of these that are in yellow will hopefully turn to white. This is the big one we're looking for right now. What are the chances of life showing up on another planet, even microbial life, abiogenesis? Right now, we only have a sample size of 1. So it could range anywhere from life forms very easily on other planets to this is the only place. You know, it depends on how you look at it, how optimistic you are. You're kind of getting in the field of astrobiology when you get into some of these variables. And each time you go down, let me back up a second. Each time you go down, there's more and more variability. I think this chance of life showing up will be discovered fairly soon as they start to look at the icy moons of Jupiter and Saturn. They're either going to find out we're the only life in the solar system, and they'll have to downgrade that number that maybe the chances of life showing up are pretty slim. Or if they find bacterial life on these different moons around Jupiter and Saturn, then that number will go up in probability, okay? We're actually on the verge of finding some of these others down here with some telescopes that they'll be launching, and I'll talk about that. But L is the big wild card, the length of time that a civilization survives to release signals into space. 30, 40 years ago, we didn't take that much credence. We thought, oh, civilizations will develop and they'll continue to use radio. What we're finding out now, radio is becoming more efficient, and we're actually leaking less radio waves into space over time. And some scientists have estimated 100 years from now, we will leak virtually nothing into space. So if you're a civilization that's developing, there may only be a 200-year window where you give off radio. So if we're listening to civilizations, they've already passed that radio signal, you know what I mean? You got to catch a civilization that's in the same stage of development as you are to get a radio signal from them. Because now we're starting to realize there's different ways to communicate, better ways, and radio isn't the most efficient way to communicate. As it turns out, one of the most powerful signals that goes into space, it's kind of ironic, if an ET were to listen to us, would be our radar systems from our military. And the signals we send to submarines, they would probably think we're a very military type country because those are the powerful signals going into space. So is SETI a valid scientific endeavor? What do you think? Let me see a show of hands. Do you think SETI is good science? Raise your hand. Do you think it's bogus science? Raise your hand. Oh, easy crowd here. I don't have any convincing to go on. If you follow, I always tell my students, to be scientific, it has to be sound, repeatable, and falsifiable. And SETI fits under that umbrella. It's good, sound science. It's mainstream science. Not a lot of scientists will get into it because you may spend your whole life and never make a discovery. You may never get published on a large journal because there may not be life for you to discover. So it's not something that scientists are all rushing to get into, but it's based on good science. It's repeatable. If they do get a signal from a distant star system, they should be able to repeat it, and they should be able to day after day go back and measure that signal and definitely determine that signal is not coming from a satellite on Earth, it's not coming from Earth, it's coming from a star system. Multiple receivers have picked up the signal. That's what good science is about. Frank Drake also said if we don't make a discovery, it doesn't mean there's no life out there. So the failure to make a discovery doesn't prove anything either. It might prove that life is very rare, but it doesn't prove that life doesn't exist. Talking about signals, this was mentioned last week, there was a signal that we actually thought could have been the real deal. It lasted about a minute. It's from the Big Ear at Ohio State University, which is now a golf course. But that thing picked up a signal for about 72 seconds in the hydrogen band, and they didn't know what it was. And they thought maybe it was somebody messaging us. They went back and looked in the same region as Sagittarius, and nothing was there. So an astronomer was looking at the orbits of all the comets and asteroids at that time, and they said there was a good probability it could have been hydrogen left behind from one of the comets. And they're not 100% sure, but they're thinking that might have been what it was. But it's still one of those things where, wow, we got a signal. They even wrote wow on the chart where, it stood out for 70 seconds and what it was. So we've gotten some signals, but, we're still not 100% there. The opposite of SETI is something called METI, maybe a little more controversial. 1974, Arecibo, the big 1,000-meter dish. They just got a whole bunch of new equipment installed, and they wanted to celebrate the power of this new equipment and what it could do. It wasn't really to try to make contacts with aliens. It was kind of, the analogy I give is when you have a new ship and you launch it and you take the champagne bottle and break it on the stern. That's kind of what it was. It was kind of like, look at what we can do with this new equipment. And they beamed a signal, and by varying the frequency, they kind of turned it into digital pulses. And this is the signal that they beamed up into space towards the globular cluster in Hercules M13, 25,000 light years away. Now, because of the rotation of the galaxy, it won't hit dead center in the cluster, but it'll still get a good part of the cluster. And if you look at that from a scientific point of view, a scientific eye, some things are going to stand out. Okay? Yeah, you see the humanoid figure there? One of the coolest things that I like about this is if there are any people living in the M13 cluster, Pluto is a planet. They should have never taken Pluto off the list. Because look at that. We got the Sun, Mercury, Venus, Earth flipped up at the humanoid, and Pluto is on the list. So no matter what they do, that signal is going out at the speed of light. They can't take Pluto away. So it is a planet. But no, in all seriousness, they basically said that the digital codes of 1 to 10 so that you could count and decipher what it means. And then once you can count, the universal language of chemistry, everybody knows 6 is for carbon. So they gave the codes for the elements that make up our DNA, carbon, nitrogen, hydrogen, and oxygen. And then over here, they have the sugars that make up the base pairs and the adenine and the thymine. And then they have the DNA strands here and here. And then, of course, the humanoid figure and the telescope that it was sent from. So kind of neat. If you think about it from a scientific point of view, it actually kind of makes sense. But like I said, their intention wasn't to make contact. By the way, this has become controversial. They did another one, I think it was in 2017, and Stephen Hawking, when he was alive, talked about this, and they said, maybe it's not a good idea that you advertise that we're here, because the experience of history is such that when a more advanced civilization meets a less advanced civilization, it usually doesn't work out well for the less advanced civilization, hence the Native Americans, you know what I mean. So that was kind of controversial. So now they say, if you're going to do that, make sure we all vote on it, we okay it, and there's a good reason why you do that.
What's the N in METI?
What's the, messaging extraterrestrial intelligence. So the reverse of SETI rather than listening. With all of this computational data that they get from the Arecibo telescope and the Allen telescope array and these other ones I'll show you, processing that data is very expensive, and SETI's on a shoestring budget. How do you process it all? Well, they came up with this really ingenious idea. Take the data and send it out in packets of information on the internet. If there's one thing you can remember tonight is when you go home, on your computer, go to SETI at home, and you can download this program. I did it. It's really cool. When your computer's in the sleep mode, it'll take that information and it'll process it. It's basically looking, you know, the old 70s receivers, and you're scanning the radio dial, and when you get a station, the signal goes like that. It's kind of looking like that. Wherever there's a spike in the signal, boom, a red flag would go off. They would take that information and send it back to Caltech, and they would reanalyze the data. Was this Earth-based interference or what it was? In 2008, it hit the Guinness Book of World Records for the largest computation ever completed. So it allows them to process massive amounts of data, and the number of people who have done it is about equal to the population of Colorado. So if you imagine everybody in Colorado doing this SETI project, that's about worldwide how many people have been involved with this. So it doesn't hurt your computer. It only processes it when it's in sleep mode. And then when you go to do operations or whatever, then it goes to about its business. So pretty cool program, and it's a cool desktop. I mean, that's the ultimate science desktop right there. You can kind of see it going in the background. Okay, this might have made news, and I got to work on the pronunciation. Amua? Is that how you pronounce it? Help me out here. Okay, we'll go with it. It's Hawaiian. But using the Pan-STARR telescope in Hawaii, just by accident, they discovered this object. This is an interstellar object, not a regular asteroid like goes around the sun. This came from another star system. They actually looked at its trajectory more recently and realized it probably came from the Pleiades region. So one of those star systems in the Pleiades region that had planets, somehow that object got ejected out and it went around the sun, and they caught it just by accident. Some Hawaiian astronomers has that name because it means distant messenger in Hawaiian. And it zipped around the sun, and now it's heading out. Well, there was something mysterious about it. It accelerated faster than it was expected to by the laws of gravity as it went around the sun and headed out. So that would be normal for a comet without gassing. They looked for outgassing and they didn't find any. Now it could have just been out of their visible range of what they were looking for. So right away, the SETI project jumped on this and scanned it with radio telescopes. Because wouldn't that make the ideal thing? If you were going to explore other star systems, you send probes to them. You gather data and boom, it goes back. They didn't find any radio signals, but it just kind of lets you know that SETI's involved with current research. Something like that's discovered, boom, it goes on their radar. Is that thing sending out radio signals? So far it's still kind of a mystery. They'll probably figure it out. But as it is right now, we don't know why it's accelerated away from the sun. It's got a very odd shape. It's very long, and its color is very different too. So it hasn't been bombarded by the radiation of a star. So its color is slightly different. Yes? Yeah, artists represent, yeah, that's art illustration at its best, right there. They have no idea how it looks up that close. If you look at the actual, the computer images, it's a blip on a screen, and they deduce some data from that, but that's what artists can do. And, when they describe the data they're getting, that it's very long shape and, yeah.
The ratios are essentially correct.
Yeah, it is, like, that's not a typical shape of an asteroid. Maybe it's something in a collision that broke off, and then now it's, this thing floating through space with no star system to belong to. So it's going way too fast to be held in by our sun's gravitational pull. Okay, so what's SETI doing now? It's not so much we're using Arecibo anymore. These are the two big ones that SETI's working on. The Allen Telescope Array, you might have heard of Paul Allen, who was Bill Gates' second-hand man, just passed away, donated $300 million to the Allen Telescope Array for 42 dishes. The ultimate goal is to get about 350 dishes. Incredible facility. They get to use it in the nighttime from 6 in the evening till 6 in the morning. And then I believe it's the Stanford Research Institute uses it in the day. So they can scan high-tech receivers there, 6-meter dishes, can scan multiple bands, multiple frequencies, scanning the sky. And to me, the most impressive thing is this Project Breakthrough Listen. 100 million donated by Yuri Milner, a wealthy Russian millionaire who basically is interested in SETI. And they're using the big 100-meter dish at Green Bay. If you can imagine a football field turned into a dish and is rotatable and steerable. What an incredible machine. In one day, Breakthrough Listen generates more data than what 1 year of SETI used to do. So they're gathering incredible amounts of data very fast on multiple channels. Seth Shostak is how you pronounce his name. He's kind of the head spokesperson for SETI. He believes, based on this Project Breakthrough, that by the year 2020 to 2025, our odds are better than 50-50 of listening in for an intelligent civilization. And he's a pretty conservative scientist, so to come out and say that is pretty bold for him. But what SETI's doing now is so much more advanced, so much faster. Things are moving compared to what it was back in the 80s and the 90s, where things were at a slower pace. They're not putting all their eggs in one basket. Some astronomers have said, well, if you got an intelligent civilization, you could use a infrared laser, aim it at a planet, and pulse it very fast. And that infrared signal would stand out from the heat and light of the sun. So they have some telescopes at the Lick Observatory, and they use automated telescopes and receivers to look for pulses of light very fast that might be coming from an intelligent civilization. So it's not just radio wave, but that's a very small subset of SETI that looks for that. But they do look in other frequencies besides just radio. The ultimate SETI telescope would be this. A little hard to explain, but if you know something about gravity waves, Einstein showed that gravity bends light. Well, normally when you take a telescope, you take a dish and you focus the incoming radiation. A lens does the same thing. It takes a light and it focuses it. Well, as it turns out, our sun takes radiation, whether it's radio waves or visible light, and it bends it. And if you go to follow that bend to where it comes together to the focal plane of where it's bending the light, you end out about 550 astronomical units. So to put that in perspective, that's 14 times further than Pluto. But talk about the ultimate place for a SETI telescope or any type of telescope. If you can get something out there, the data I read on it, put this in perspective here, the resolution you would get on a planet that's 9 light years away is down to 10 kilometers. Now the Hubble Space Telescope can get a resolution of Mars of 40 kilometers. So what that means is you could get images clearer of an exoplanet than the Hubble Space Telescope can do of Mars right now. The problem is getting a probe out there. That's a heck of a distance. The Voyager probe, which is our most distant probe that's beyond our edge of the solar system now, Okay, it went 39 years to go 137 astronomical units. So it's not like you can just build a probe and just send it out there. You have to have advanced rocketry to get it out there within 30 or 40 years. And then the one disadvantage you would have once you get out there is you're based on your line of sight. So once you image a distant planet, you're rotating, there goes your shot. You know what I mean? You have to wait an umpteenth century to come back around or whatever, unless you had two of them side by side. But with a telescope out there, think about what you could do. Spectroscopy, when you take a spectroscope and you hook it to a telescope, it tells you what elements are in a star. You do something like that out there, and you can get a detailed spectroscopic analysis of a distant planet and look for biosignatures. Oxygen with methane and carbon dioxide is a biosignature, not just oxygen, but those gases in particular. And you would have verifiable proof that there's living forms of life out there. You don't know if they're intelligent or not, but that would be an ultimate SETI telescope. Something to think about, maybe in our lifetime. So they plan about it, they talk about it, but it's, funding's an issue. Okay, speaking of funding, that's a kind of dismal sight right there. So there's the funding of SETI. So it peaked in 1991 at about 13 million. And kind of controversial, in 1994, some things were said in Congress where basically they said, what are you doing spending tax money looking for little green men? And it got a bad reputation. That's not good science. So no politician wanted to be associated with SETI because your chances of winning the re-election are pretty slim. To put that in perspective, when SETI was at its maximum funding, that's about 1/10 the price of an F-22 fighter. So it's just a very small amount is all SETI's been funded. The way I look at it now, though, the reason why they cut SETI is because if the aliens do come, you got the F-22s to shoot them down. So that's how they kept it going. Okay, so.
Don't make F-22s anymore.
So SETI does have its critics. We've been looking for 50 years and haven't found a signal. If you understand SETI, it makes sense because the early days of SETI were very primitive. Now it's really ramped up and they're scanning a lot more stars at a lot faster rate. And intelligent civilizations may only leak radios for 100 to 200 years, so your chances of catching them are very slim. But the biggest critic probably comes from the idea of the Fermi paradox. It's just kind of interesting. Enrico Fermi, brilliant Italian-American physicist, worked at Los Alamos on the Manhattan Project and did some calculations in his head and said, if the galaxy's 13 billion years old and you had a type 2 civilization that did generational spaceships, they could colonize the Milky Way in 2 million years. And his facts are facts. It could be done. So he said a basic question. Because you could do this in 2 million years and the galaxy's this old, we should see signs of them everywhere. So his simple question is, where are they? And that became known as the Fermi paradox. And if you follow the logic, it actually does make sense. If intelligent civilizations were common, you would see the hallmark of them all over the place. So I mentioned a type 2 civilization. This is based on the Kardashev scale of how much energy a civilization uses. So a type 1 civilization would use all of the energy available to their planet. And on that scale, we're about a 0.7. We're not using all the energy available on our planet. As you develop, as a civilization grows and develops into a type 2 civilization, it would use all of the energy of its star. And that's how the ideas of something like a Dyson sphere comes about. You might have heard with Tabitha star or Tabby star, basically a superstructure that harnesses all the energy of that star. And then as you develop into a type 3 civilization, you harness all the energy of your galaxy. These two civilizations would leave hallmark signatures that would be fairly easy to detect with sophisticated equipment, and we're not seeing this. So it's making us wonder if maybe that value of L, the number of advanced civilizations, is smaller than what we thought it was. So that's the Fermi paradox. Some people buy into it, and that's their foundation, and that's their stone, that's their rock, and there's no life out there because of that. Other people look at it and get a little bit from it. It's kind of pick and choose what you want to go with. And I like this quote here. 2 possibilities, either we're alone or there's life out there. And to Arthur C. Clarke, both are terrifying. I don't know, it depends on how you look at it. If we're alone, that's a lot of real estate. That's the way I look at it. But at the same time, you have to ask yourself, why are we alone? Is it just, a lottery ticket, cosmic chance? So something to think about, that'll keep you up at night. All right, so now going into the stuff that everybody came for. This is the interesting stuff, the ufology. UFOs, do they exist? What are they? My son told me not to put that in there, but sorry, Sven. I had to get that in there. At least I took off the Voyager probe with the naked man and woman on there. That was really controversial. Okay, so ufology. Before we head down this path, word of caution. you always have to be careful because the eyes and mind can be easily deceived. And I'll tell you about 2 UFO stories I personally have and how that fits into the context here. So living in Colorado, you see a lot of these things, lenticular clouds. My sister comes out to visit from Ohio. They're like, wow, that cloud looks like a flying saucer. I'm like, we get them here all the time, you know. But this one's actually a little more controversial here. Let's say you're strolling along in the Atacama deserts of northern Chile, and you see this thing wrapped up in a white cloth in a nitrate mine with a purple ribbon around it, and you unwrap it, and you see this strange structure. It's got 10 pairs of ribs instead of 12, deep elongated eye sockets, a very elongated skull, it's, you know, that big. What's going to go to your mind? Of course, you're going to think, that's an ancient alien, okay? When you do further investigation and you do a testing of the bones, which they did a genetic testing of the bones, they found out it's actually human. It was of Chilean descent, and it had 3 genetic markers on its DNA that attributed to skeletal deformation, which is what caused that skeletal to be that shape. It was probably stillborn, probably was never alive, but when you first see it, before you look at it through the lens of science, you tend to jump to conclusions. They do this all the time. Whenever there's a new discovery, the first thing you jump to is aliens. Maybe it's right, maybe it's wrong, but that's what makes the headlines. But when you follow it up with science, it doesn't always lead down that path. So you got to be careful because the eyes and minds can be easily deceived. Here's some other examples. Boloids, okay, fireballs. Venus on the horizon. Astronomers know this all the time, but when Venus is low on the horizon, Venus is the brightest object in the sky compared to the sun and the moon. And when it's low on the horizon, it'll twinkle due to atmospheric turbulence. It looks just like a hovering light, like a flying saucer. Of course, you got the military. The stealth fighter was made, and before they released it that it was here, you know, it was flying around. So if anybody saw it, they didn't know what it was. The Russians launched this satellite up north, and in Norway, it made these spirals. You get all kinds of things like this. Here's a personal picture I took. Anybody would look at that. I could probably publish that in the Sun magazine, and they'd say, look, it's a flying orb right there, okay? I was up on Cameroon Pass in the middle of December. It was like minus 20 degrees, and a car headlight reflected internally in the lens, but look at what it makes. I was there. I knew there wasn't an orb, okay? But that's what shows up on the picture. So you see stuff like that all the time. This one caused mass hysteria in Belgium in 1990s. This guy took this picture. It turned out to be a hoax, but when it was published, all of a sudden everybody was seeing these triangular objects in the sky. So it kind of fed on. 2 UFO stories I have was one, I was in my house where I live in Loveland, and I was coming from the garage into the house, and I was walking in, and I looked up, and 2 beautiful glowing balls moving pretty fast about 2 seconds ago, shh, and they were flying like, you know the way dragonflies fly? They were kind of going through the sky like that, and this beautiful orange glowing color. And I go in the house, I got goosebumps, I'm like, what was that? You know, I'm just like shaking for a week. I was thinking about it and thinking about it. And as the emotion settles down and you start to think about it, you start to realize what I was probably in the unique perspective of being directly underneath a fireball or a boloid. And it was probably way overhead and it landed somewhere in Canada. That's probably the most likelihood of what that object was. But when you see it, and because most of the time when you see fireballs or like the Gemini meteor shower going on, you're seeing them off on the horizon. But to be directly underneath it was a whole different viewpoint I'd never seen before. So I'm going with that for now. That makes the most sense to me. I can sleep with that. But it was still fascinating, that week that went by until your emotions settled down, thinking about what it was. The other event that happened was, and I have witnesses for this one, I was with Dr. Rideout, and we were doing a 9th grade star night. This was back right after after the 9/11 event happened. It was the following year. So it was 2002. It was a beautiful fall evening. I was on the ladder looking through a Dobsonian telescope, and Dr. Rideout was right next to me, and I had a student that was also looking through the telescope, and we saw this. It was a black object, very large. There was a tiny little light at the corner of each of this triangle, and the weirdest thing about it was dead silent. Didn't make a sound at all. You could tell it was there because it was a clear night, and it was blocking out the stars as it moved overhead. Had no idea about how high up it was because I didn't have any surface features to tell me height, you know what I mean? And I couldn't hear a sound at all. But Dr. Rideout saw it clear as a bell, and I trust him more than I trust me. Some of the kids saw it, and we were all like, wow, what was that? Now, in all probability, it was probably some kind of military surveillance plane that was on silent mode. I don't know, you'd have to talk to people in the military. I'm not in the military. I'm going with that as a probability, but all I know is it fits the class of a UFO. It was unidentified. We didn't know what it was. And multiple people saw it. We all saw it together, so we know it wasn't a hallucination or anything. But when you look at it through the lens of science and logic, It was probably a military aircraft, but at the same time, we didn't have enough information to tell, how high it was or whatever. And I've talked to countless people who've seen weird things like that. And it gets your interest going. It makes you think about. And the way I keep telling my students, keep looking up. When they ask me to sign their yearbook, I always end up with keep looking up, keep looking at the stars, keep learning about stuff. Okay, so it's good. It kind of feeds science. So is ufology a true science? I always tell students to be scientific, you have to be able to falsify it. Ufology is a little bit different. It's hard to falsify it. It's based more on eyewitness accounts. It's like somebody saw this somewhere, you know what I mean? And is it repeatable? Usually not. That's the problem with ufology versus SETI, which is designed to be scientific and repeatable, okay? With that said, MUFON is the most scientific approach you could get to coming up with a database of whenever somebody discovers a UFO or says they saw an unidentified flying object, they can report it to MUFON and they would keep it in a database to track where are most of them being reported. Are they more along the East Coast? Are they always by a military base? Is there a new plane being developed? And they kind of correlate those two together. So that's what MUFON's about, is just looking at it from a logical point of view of tracking where these UFO sightings are said and put it on a database. So there is some legitimate, if you want to call it, in the verge of science of tracking that stuff down. Probably the most famous UFO case everybody knows about is Roswell. And you could go on and on about UFO cases. We don't want to head down that path because it kind of turns into a he said, she said story. And it depends on what part of the internet or what blog you're on or what YouTube channel you're on under what you're going to get. The military says it was a weather balloon, part of Project Mogul, coming out of Alamogordo that crashed, and the UFO community would say something totally different. Okay, so I don't want to go down that path. But I do want to play this because I think this short little video clip, if we have time, this short little video clip demonstrates the difference between how science looks at ufology and how the everyday person looks at ufology. Do we have like 4 minutes to show this? Okay, so I'll need, Mark, if you could hit that video in the back there, just hit play. I think we have sound there. Watch it through the lens of a scientist and watch it through the lens of the pilot.
If you've been online at all recently, you've probably seen this video. This is one of 2 clips released by the Department of Defense. Both videos show a thermal image of an unidentified flying object. The videos have been widely shared and scrutinized. A lot of people think that this is the first real evidence that extraterrestrials exist and that they're visiting us here on Earth. There's just one thing. Most people in the scientific community don't think these videos prove anything. People have been claiming to see UFOs for decades. Countless videos purporting to show alien aircraft have been popping up since the invention of film. But this video is unique. It was released by the Department of Defense, which found the video noteworthy enough to study, then release, which is a first for the U.S. government. Until 2012, the DoD says it ran a secret advanced aerospace threat identification program. The program was funded by $22 million worth of, quote, black money. Those are funds the Pentagon sets aside for classified programs.
Both of us, both airplanes, see disturbance in the water and a white, 40-foot long, tic-tac shaped object.
This commander was one of the Navy pilots that spotted the UFO.
I get over to the 8 o'clock position, it's at about the 2 o'clock position, and I decide I'm going to go and see what it is, and it's about 2,000 feet below me. And I cut across the circle, and as I get within about a half mile of it, it rapidly accelerates to the south in about 2 seconds and disappears.
All this seems pretty incredible, right? So why don't scientists care?
So I think it's very, very difficult as a scientist to look at something like this and say anything except, it's intriguing.
We spoke to Caleb Sharp. He's an astronomer and director of the multidisciplinary Columbia Astrobiology Center.
But I would need a vast amount more documentation and context to really understand what's going on here.
Yeah, because I think that's exactly there. One cannot tell much from the video.
That's Carolyn Fruge. She's an assistant professor at Purdue School of Aeronautics and Astronautics.
Yeah, I would like to know more about what wind was, kind of what were the turbulence.
There's a lot of unexplained natural phenomena on the Earth and in the Earth's atmosphere that
What they're talking about is the scientific method. Basically, before scientists will accept something as fact, a lot of research and testing has to be done. And it has to take place in a controlled environment.
You can't really set up a thorough, proper scientific experiment. It's all reliant on serendipitous data. And that's one of the difficult kinds of problems to solve in science. So I'm not surprised that we don't have a good answer yet.
But these videos were released by the U.S. government. There has to be some significance there, right?
I suppose there's a spirit of openness about it. And if you don't know what you're looking at, then throw it out to the world and say, look, this is what we got. You can interpret it in a variety of different ways.
If we're just going off of the scientific method, hard evidence and a cacophony of data are the best metrics for explaining this phenomenon. But what if you did see it for yourself? Would you still need an experiment to explain it?
So bottom line, what do you think this was?
I believe, as do the other folks that were on the flight that when we visually saw it, that it was something not from this world.
The commander is not alone. The videos continue to be scrutinized by a lot of people who think that this is an alien spacecraft. As for the DoD, other than releasing the videos, they haven't said much. Presumably they have access to more data from the flight and from reports made immediately after the encounter. Releasing more info could begin to answer scientists' questions. But ultimately, even that might not be enough.
Yeah, on the one hand, I could be really cynical about all of this, but I think it's wonderful that people are intrigued by phenomena that they see out in the world. That's a good thing, that's a positive thing. Our curiosity is a positive thing. And to be honest, if there are any strange things floating around up there, I'd like to know what they are. The difficulty with this kind of problem is that you can't plan for it.
Okay. See if that'll go to the next slide there. I lost control. You might have to run it there, Mark. We'll go to the, okay, perfect. So, but did you see the difference between how the pilot talked about it and how the scientists talk about it? Through the lens of science, and I'm a science teacher. Science is what guides my life in my everyday profession. Through the lens of the scientific method, you would be stretching it to say that was a UFO because of the repeatability, the not knowing all the information. But through the eyewitness account, he was pretty confident he saw what he saw and he knew what it was. Do you see the difference between how the two look at it? I'm not saying one's right or wrong. I'm just saying viewing the same object through different lenses will give you different answers. Does that make sense to how SETI is in the ufology of that? I do want to mention this one. I've researched to do this presentation, all kinds of UFO encounters. I got to say, this is the most fascinating one. I'm not going to play a video from it or anything, but there was a school in Zimbabwe in 1994 where 64 children witnessed something, and you can hear their videos because a Harvard professor recorded them online 2 days after it happened, and those are all on YouTube. But a very fascinating thing. And I always like to go to how UFO events are debunked. You know, what's the kind of weird fishiness about this story? And I've yet to find something that's very definitive that can really debunk this phenomenon, because they've done follow-up interviews with these children that are now in their late 20s, and they've talked about this event and how it was probably the most instrumental event in their life. Like, they'll never forget this event. It left an impression on them like you wouldn't believe. But anyway, fascinating story there. I'm not going to have too much time to get into interstellar travel. I'm going to kind of wind it up because I'm looking at the clock back there. Yeah.
It's pretty cloudy out there. So
Okay. All right, I'll go back. I'm not going to drag it on. Just 4 more slides. Okay. All right. All right, so if aliens were visiting us or extraterrestrial were visiting us, or if we wanted to visit other planets, you run into this problem. A little bit of science, if you know something about Einstein's equations, as your spaceship gets faster and faster, right about the 80% of the speed of light mark, something incredible happens. And it's not magic, it's science. E equals mc squared, your mass gets more intense. As you put more energy into your spaceship to go faster, that energy turns into mass. And when I first explain this to kids as I'm teaching science, I'm like, you can't go faster than light. Well, like, why not? You just put a bigger engine in your car, you go faster, okay? But I'm like, no. As you put more energy to go faster, you turn that into mass, and you get heavier, and it's harder to make it go faster. So you run into this asymptote here, where it makes it impossible to travel faster than the speed of light. You can't cross that. As you try to go faster, you get more mass. So reaching maybe 80% of the speed of light, okay, and anything beyond that, pretty difficult. So you'd have to come up with some alternative method to travel large distances in relatively short periods of time. I mean, science fiction talks about folding space and stuff like that, but that's, you know, beyond the realm of what we can do. In terms of the time-distance barrier, though, put it in perspective. If you built spaceships, not with people in them, but with, you know, robots that would all of a sudden become alert, or AI, or some kind of recording mechanism to travel to the stars, and you built many of them and sent them out to the stars, you seem like, oh, it would take forever to get there. But in reality, look at plate tectonics. I just taught this lesson in geoscience the other day. About the amount of the speed that your fingernails grow, 2 centimeters per year, maybe a little bit faster. At that speed, the Atlantic Ocean formed in only 4% of Earth's history. So traveling to the stars really isn't out of the question, as long as you put in the time factor and you allow that time factor. So it is possible to send probes to the stars, just don't expect to get information back in a relatively short period of time. But if you're an advanced civilization that's been around millions of years, you've got time on your side, and that's a doable thing. So it all depends on how you look at it. Do you look at it through the lens of time or distance? You got to look at it both. So right now we could build this spacecraft, okay? It's called Project Orion. It wouldn't be a fun spaceship to go on. Basically, you take hydrogen bombs or some kind of thermonuclear bomb, you put up behind you, and it's like a putt-putt boat. It's like, boom, the bomb goes off, and it gives you a shove. And then you put another larger bomb, and boom, it gives you a faster shove. You do that for about 100 years, and you get up to about 0.3% of the speed of light, okay? Now, it turns out it would take you a little over 1,000 years to get to the closest star. But it's doable. You could build it. You wouldn't want to send humans on board, of course, something like that. But, I mean, with our technology today, it would be very expensive, but you could build something to get there. It's not graceful. To me, it's kind of like going across the Pacific Ocean in a rowboat. It's like putt, putt, putt. You know, eventually you're going to get there, but it's not very, you know, economical to think about it. If you think maybe 50 years down the road, if you've got hydrogen fusion and you can harness that energy, something called the Dalius, which is a project idea using hydrogen fusion, you could actually get up to 12% of the speed of light, and that would get you to Alpha Centauri or Barnard star in about 50 years. Okay? You couldn't slow down, you would just go right past the star, send your message back, but you know, I mean, that's maybe 50 years out. So it's not like, it's still on the horizon, okay? Sven, maybe someday. You're in that range. All right, so pulling it all together here. SETI and ufology, what do they have in common? It's pretty obvious. They both believe that there's intelligent life in the universe. Otherwise, why else would they be looking for it, or why else would they make these observations? Why would you spend your life to get into SETI if you didn't believe there was intelligent life out there? That wouldn't make any sense. So they do have something in common. Where are they different? SETI's based on the scientific method, looking for extraterrestrial in a controlled, repeatable scientific environment. Whereas ufology is more on eyewitness accounts that are not repeatable. That's the fundamental difference between the two. So there is some overlap, but they're definitely not the same camp there. Today, it was 1900, so it was 118 years ago. On this day, Max Planck made an amazing discovery. To put you back in perspective, and this I'm going to end with these 2 slides here. 100 years ago, scientists and physicists were saying, we've got it all figured out. Albert Michelson, the first American to win the physics prize, the Nobel Prize in Physics, measuring the speed of light, said all physicists need to do is get more precise instruments and measure the speed of light with more precision. And all these things we know already, we just got to get more precise. And how ironic, on this day, 118 years ago, Max Planck came out with his findings on quantum physics. Totally turned the world upside down on its head for the next 30 years. This whole new field of physics they didn't even know about comes to be. And then in 1923 to the 1930s, we have Edwin Hubble discovers these little spirals that they called nebulae are outside of the Milky Way. The size of the universe just got thousands of times bigger. And now we've got 1990s, we're discovering that galaxies are accelerating away from us. The universe is not only expanding, it's accelerating. So when you look at the whole idea of intelligent life in the universe, have they traveled to visit us or whatever, I always tell my students, don't always look at things through the lens of scientists know-it-all, because take a look at this pie graph. This says it all right now. We understand about 4% of normal matter, protons, neutrons, electrons, quarks, subatomic particles. The rest of the universe, the other 96%, is dark energy and dark matter that we really don't understand. So I look at that as that's an incentive for students to go into science, to find out more. Don't ever sit there and look at through the lens of we got it all figured out. There's no way anybody could ever travel here. The distances are too great. You're basing it on 4% of the universe that we understand, which is kind of presumptuous. So I take a more naive point of view that, well, maybe they could have been here because we don't have it all figured out. There's so much we don't know. So this is the final thing that I say to my students all the time. Keep an open mind, just not so open that your brains fall out, okay? So put it in perspective. So the debunker is the flip side of the true believer. They both approach something with a bias. Keep an open mind, but be logical, okay? So it's best to always try to find out what's true and accept that, whether it's you believe it or not, okay? This kind of the Kepler idea, where Kepler wanted these orbits to be crystalline spheres, and they turned out to be ellipses. Ellipses weren't cool. But he said, they're ellipses. That's what the data says. Go with it, you know? And virtually all breakthroughs in science come from entertaining crazy ideas. So don't be afraid to think outside of the box, but be logical and stick to that scientific method. It's kind of the approach I take. So that's how we'll end it there. If you have any questions, I'd be more than happy to answer them.
Thank you.
Yes?
Why do they call it dark matter and dark energy? Is it just because we don't know what it is? Or
Pretty much, and there's a lot more people that are more qualified to answer that than I am in here. But the dark matter they knew about earlier. Basically, you know, like if you swing a rock over your head and it's on a string and the string's faster and faster, eventually the rock will break the string and fly off. Well, galaxies should do that. Based on how fast they're spinning and all the stars and the black holes, they should fly apart, but they don't. There's some matter around them that are basically holding it together, and we know it's there because of the way it also bends light. So we don't know what it is. They keep looking, you know, there's different subatomic particles they thought it might have been, and every time they think they get something, it turns out not to be that. So the mystery is the dark, and then the dark energy is with the expansion of the universe, what's causing it to accelerate. And it's more mysteries than answers. So yeah, it's kind of just dark. I mean, they could have called it anything, but dark matter and dark energy sounds kind of cool. Does anybody want to jump in on that? We got some people that have PhDs next to their name that know a lot more about it than I do.
it's cool and we don't understand it.
Any other questions? Sven?
Well, the research of that thing when they found that UFO, the USA Department, well, I'm not sure why they didn't shoot that.
Ooh. I'm not sure it'd be a good idea to shoot at it, and you know, unless you're trying to protect yourself. Yeah, you probably don't want to shoot at it. I don't think that would be a good idea, unless you were trying to defend yourself.
And unless when you're a pilot, you're told to come back with the same amount of ammunition you go out.
Yeah, there you go. That ammunition is expensive.
You're not bringing it all back.
Yeah, so you don't just shoot at things randomly. Those are very expensive missiles you're firing. Any other questions?
Or potentially, that could have been another airplane that we didn't know about.
Ah, that's true.
They could have killed someone.
Yeah, if it was an experimental aircraft and they didn't tell their pilots it was in there, you just shot down a $5 billion experimental aircraft and killed somebody too. So,
They have bigger guns than us.
yeah. Any other questions? Yes.
The fireballs, what was the name?
So a boloid is another name for a fireball. Yeah, that's.
What causes this?
So those are meteors that are burning up in the atmosphere. Most of them are tiny little specks of dust, but when they're a chunk-sized rock, then you're going to get the fireball effect, and usually they break apart. Probably what I had saw was a larger chunk that had broken apart into two, and they were zipping along, and I just happened to be from the point of view directly underneath it, which is, I'll still remember that sight. It was really cool. Anything else? All right, well, thank you. Oh, Andrew.
I was wondering if you could say a few words about your astronomy course that you teach in the evenings and that's open to high school students from all the surrounding high schools.
Sure, yeah. So I teach the night astronomy class. it's a wonderful thing that this observatory has allowed us to, the Thompson School District, on Monday nights to have the observatory to use the telescopes, and we have a whole shed out there filled with dozens of small telescopes, and it's open to anybody in the district. We could even have students outside of the district if you enrolled through that class. So I have kids in Thompson Valley High School, Loveland High School. We meet in my classroom. On cloudy nights, we learn about astronomy like any other textbook class, and on clear nights, we're out in the observatory, we're observing. I have some aides that are trained to run some of the telescopes, and I help the kids with the telescopes in the field. It's a cool class. The kids learn a ton. It's so hands-on, especially in the fall when we have all these wonderful clear nights in September and October. I'm just getting the reports, the final project in from the kids and reading about them, and they're talking about like the first time they saw Jupiter, and it inspired them to learn about Jupiter's moons, and they write about the objects they've seen. It's a really cool class. Meets once a week on Monday evenings from 6 to 10. And like I said, it's clear. And so if you know any sons or daughters in the Thompson School District, the only requirement is they have to be a junior or senior, because the class does fill up. And I usually have about 35 kids in there each semester. So if we open it up to anybody, then we couldn't get everybody in there. So it's a junior, senior level class. But it's a great opportunity to learn about the night sky. So got some former students here tonight. So, all right. Well, thank you.